will now discuss velocity and net change. We will start by relating velocity, position, and displacement. We'll then move over to the future value of the position function. We'll talk about acceleration, and then net change and future values. So consider an object moving along a line. The position of the object at time t, which we'll denote by s of t, is the location of the object in relation to the origin. The velocity of an object at time t is given by v of t equal to s prime of t. So the velocity is the derivative of the position. The displacement of the object between times a and b is the difference between the position at the starting and final time. So we have s of b minus s of a, which is equal to the integral from a to b of v of t dt. So if we know the velocity, we can integrate between times a and b and determine the displacement. The total distance traveled by an object between times a and b, where b is greater than a, is given by the integral from a to b of the absolute value of the velocity. And we call this absolute value the speed of the object. So displacement is going to be the difference between the position at the starting and final time. However, the total distance traveled would be the actual total distance traveled. So for example, if I start here, and I walk over, and then I walk back a little bit, this position right here would be my displacement. However, that's not my total distance traveled. The total distance traveled would be this entire thing that loops back around. So the distance traveled is usually longer than the displacement. So for example, a runner jogs along a straight path with the velocity given by v of t equal to 3t squared minus 6t plus 4 kilometers per hour for times 0 to 2. We want to determine the displacement of the runner on the time interval 0 to 2. So displacement is just given by the integral over this time of the velocity. So 3t squared minus 6t plus 4 dt. When we integrate this, we raise the exponent by 1 and then divide by that number. 3 divided by 3 is 1. Increase the exponent by 1 and then divide by this number. 6 divided by 2 is 3. And then the integral of 4 is 4t. And we need to evaluate this between 0 and 2. So this is 2 cubed minus 3 times 2 squared plus 4 times 2 minus 0 cubed minus 3 times 0 squared plus 4 times 0. If we work this out, we get 8 minus 12 plus 8 minus 0, which is going to be 4. So the total displacement of the runner after 2 hours would be 4 kilometers. We now want to determine the total displacement of this runner. So the first step is to determine when this is going to be positive and when it's going to be negative, since we're going to have to integrate the absolute value. So we have 3t squared minus 6t plus 4 greater than or equal to 0. And we need to solve this. And if you solve this, you'll actually get that this always works. So this is true for all t. So this is always positive. So if we have the integral from 0 to 2 of the absolute value of 3t squared minus 6t plus 4 dt, we actually get that this is equal to the integral of 0 to 2 of 3t squared minus 6t plus 4 dt, which we just discovered was 4.